Hi, welcome back. So we're going to start in on section 5.5, which is right triangle trigonometry. And let me make some connections or help you make some connections first. So we've been working within our unit circle or within a circle, right? With effectively this little triangle right here. And we know some things. We know that the sine of the angle theta is equal to y over r. And that the cosine of the angle theta is equal to x over r. If we take our right triangle and we pull it out from under our circle, and we label our angle theta. And here's what we realize. We realize that the radius is where the hypotenuse is. And we call the side that our angle looks at the opposite side. And we call the side that would correspond to our initial side, or our positive x-axis, or the side that is actually part of defining that angle, the adjacent. And when we do that, we can realize that this means that the sine of that angle theta is equal to the length of the side opposite divided by the hypotenuse. And the cosine of that angle is equal to the length of the side adjacent divided by the length of the hypotenuse. And because we also know that the tangent of theta is equal to y over x, we know that the tangent of my angle theta is equal to the length of the side opposite divided by the length of the side adjacent. Adjacent to that angle. Now there's a shorthand mnemonic to help you remember that, and this is SOHCAHTOA. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. SOHCAHTOA. I call it my favorite exotic vacation spot. Okay, so let's talk about some things that we can do here. Let's suppose that I've got a triangle, and one of the things that moving ourselves away from that circle does is it lets us really draw our triangle in any orientation we want. The only key is, at this point in the course, we will not have this later, but at this point in the course we have to have a right angle. So there'll always be a right angle marked. And let's put my angle alpha here. And let's say that this is a 3, 4, 5 right triangle. Bit of trivia, 3, 4, 5 is what's called a Pythagorean Triple. And remember that there's a relationship between the sides of a right triangle, which says really that the hypotenuse squared is always going to be equal to the opposite square plus the adjacent squared, in the way I've got that triangle labeled. There are specific sets of integers that satisfy that equation, and those are called Pythagorean triples, and 3, 4, 5 happens to be one of them. Just a bit of trivia, but right now in this video what I want to do is I want to find the cosine of alpha. Well, cosine is the length of the side adjacent to the angle divided by the hypotenuse. In this case, the hypotenuse is 5 because 5 is the side that is opposite the right angle, and the side adjacent to my angle alpha is 4. So the cosine of alpha is 4/5. We can find the sine of alpha. Sine, the sine of an angle in a right triangle, is the length of the side opposite that angle divided by the hypotenuse. Now, I wrote that down as I was talking. What I want you to realize is that 3 is the side opposite, and of course 5 is the hypotenuse. And the tangent of this angle alpha is the length of the side opposite divided by the length of the side adjacent. Now, those are sine, cosine, and tangent of alpha, but suppose I label this angle over here beta. Well, cosine of beta is the length of the side adjacent to beta divided by the hypotenuse. The hypotenuse is unchanged, but if we look at where beta is in my triangle, the length of the side adjacent is now 3. The sine of my angle beta is equal to the length of the side opposite beta divided by the hypotenuse. So again, my angle beta, the side opposite is that one. And then tangent beta is the length of the side opposite beta divided by the length of the side adjacent. So we need to be careful and make sure we know which angle we are working with in our triangles. And I want you to notice something. I want you to notice that there is an equality between the sine of one of these angles and the cosine of the other. And that is true in both of these cases. And in fact, that is always true. If, this is called the cofunction identity. Cofunction identity. And I'm going to write this out a couple of ways. The first way I'm going to write this is that if alpha plus beta equal 90 degrees, and we can do this in radians as well. Then cosine alpha equals sine beta, and sine alpha equals cosine beta. Now your textbook writes this a little bit differently, and I think that your trig cheat sheet also writes this differently. So here's what I want you to think about. If alpha plus beta equals pi over 2, that means that alpha equals beta, equals pi over 2 minus beta. This leads you to, I hope fairly quickly, the fact that the cosine of, and we could also write that beta equals pi over 2 minus alpha. So what I hope this leads you to is that the cosine of alpha is equal to the sine of pi over 2 minus alpha, and the sine of alpha is equal to the cosine of pi over 2 minus alpha. And this is true for any angle alpha. The cosine of the angle is always going to be equal to 90 degrees minus, the cosine of the angle is always going to be equal to the sine of 90 degrees minus that angle. Or pi over 2 minus that angle, because those are the same thing. All right, I'm going to stop this video here, and we'll come back in a separate video and solve some problems. I'll talk to you in a minute.